Okay, today we're going to talk about Chapter 4, Section 4. Again, we're going to talk about the average value theorem and the mean value theorem. Sometimes these will be referred to as the AVT and the MVT. The average value theorem tells us that the average value of a function over an interval a to b is found by taking the integral from a to b of that function and dividing by b minus a. So when we think about that, what we're doing on the top is we're adding up all of the heights, right? We're taking the area under the curve. We're adding up all of the y values and then dividing by the difference in the x values. So the average value is given by the integral from a to b of the function divided by b minus a. This is just a formula that you need to know, and anytime you see the phrase average value in an FRQ or a multiple choice, this formula should come to mind. So we'll do a couple straightforward questions to find the average value of 3x squared plus 2x over the interval 1 to 4. I see the words average value, so I'm thinking the integral from a to b, which is from 1 to 4, of the function 3x squared plus 2x divided by 4 minus 1. So I evaluate the integral on the top. That's going to be big F of 4 minus big F of 1 over 3. I find the antiderivative for that integral. The antiderivative, big F of x, is equal to x cubed plus x squared. So I evaluate it out, and I get 64 plus 16 minus 1 plus 1 over 3, or 78 thirds. That represents the average height, or the average y value of that function between 1 and 4. We'll take this as an opportunity to also review u sub that we learned yesterday, like the extra x u sub. So I want you to find the average value between 1 and 4 of this. We'll set it up first, and then I'll ask you to do the u sub. So just using the average value formula, this would be the integral from 1 to 4 of x times x minus 3 cubed over 4 minus 1. I'll give you a couple of minutes to do u substitution to evaluate the integral in the numerator. Alright, so here's the solution. U equal to the n, du is equal to dx. I've got an extra x, so I've solved for x. I do my u substitution, and I get this as the integral. Notice that I changed my limits, the integral from -2 to 1 of u to the 4th minus 3 u cubed. I evaluated my u substitution and got the average to be that answer right there. Alright, now for the mean value theorem. The mean value theorem guarantees that there is some c between a and b for which f of c is equal to that average value that we just learned. Alright, so that means that if the function is continuous, I can guarantee that there is some x value c that will give me that average value. Now this seems pretty complicated, but it basically in real life can sort of be explained like this. If you tell me that you drove from Orlando to Miami and you averaged 60 miles an hour, I know at some point during that trip you had to have been going 60 miles per hour. You didn't have to be going 60 miles per hour the entire time, but it's impossible to average 60 miles an hour without at least going 60 miles an hour for one single moment in time. So I'm guaranteed at some point in that trip, your speedometer said 60 miles an hour. That's what the mean value theorem guarantees. Alright, so how is a MVT, mean value theorem, question worded? It usually works out where they ask you to find the average value of a function, and then they want you to find the c that's guaranteed by the mean value theorem. There's normally a wording that says such that f of c equals the average value. Alright, so let's work through this together. First, let's find the average value. Well, the average value here is given by the integral from -2 to 2 of -6x squared plus 6 dx over 2 minus -2. So that's going to be equal to that integral over 4, right? Big F of 2 minus big F of -2 over 4. What's big F? Big F is going to be equal to the -2x cubed plus 6x. Plugging that in, -16 plus 12 minus 16 minus 12 over 4, which gives me -32 plus 24 over 4, or -2. Now, find c guaranteed by the mean value theorem such that f of c is equal to the average value. So I'm trying to solve f of c is equal to -2, or -6x squared plus 6 is equal to -2. Solving, I get x is equal to plus or minus the square root of 4/3. So the mean value theorem guarantees me that there's one value. In this case, there happen to be two places where the y value was equal to the average value over that given interval. Just like in my example of you driving to Miami, if you average 60 miles an hour, it doesn't mean that you were only going 60 at one moment of time. You could have been going 60 multiple moments in time. I'll give you about 2 or 3 minutes to find the average value of this linear function over the interval -1 to 3, and then find the c guaranteed by the mean value theorem such that f of c is equal to the average value that you find in the first part. Here's my work for the average value. I plugged it into the average value formula, found the antiderivative here, found big F of 3 and big F of -1, and got a average value of -3. To find the c guaranteed by the mean value theorem, I take f of c, I set it equal to -3. I plug in c to my little f function, and I find c is equal to -1. Here are your homework problems for tonight. The answers will be on Edmodo this evening.